Far away in the outskirts of our solar neighborhood, Pluto lurks like a quiet little troublemaker. This icy world, once proudly included among the official planets, has become the center of renewed attention thanks to some eyebrow-raising comments by space science icons Neil deGrasse Tyson and Michio Kaku. Based on their most recent concerns, Pluto might be creeping toward a potentially risky encounter with Neptune. But how could such a thing occur at all? What are the real consequences? If this frosty loner collides with its significantly greater celestial neighbor, is this only another bizarre turn in the endless space drama, or are we just on the brink of something truly game-changing? Strap in as we dive headfirst into the strange and spellbinding possibility of Pluto smashing into Neptune. Pluto may have been demoted to a dwarf planet, but it never left the curiosity spotlight. Modern scientists closely monitor it, and recent ideas from top minds suggest Pluto's orbital path creeps dangerously close to Neptune. Tyson and Kaku aren't just tossing wild theories. They're legitimately worried that these two cosmic wanderers might one day clash in a big way, and that could spell serious consequences, even for us here on Earth. But how on Earth, or rather, how in space, would that ever occur? In contrast to the big planets that orbit the Sun in neat circular-ish paths, Pluto's route is wildly eccentric. In fact, it takes Pluto almost 248 years to complete a single loop around the Sun. Since we discovered it back in 1930, Pluto hasn't even had time to finish one complete lap. But that's just the beginning of Pluto's oddities. It doesn't play by the same orbital rules. Instead of gliding along the flat plane most planets share, Pluto's path tilts at a sharp 17 degrees. That makes it orbit as if it is attempting to cut through the rest of the planets at a weird angle, sort of like a cosmic rebel ignoring traffic lanes. Fascinating and slightly frightening, isn't it? For approximately 20 years in each orbit, Pluto actually swings closer to the Sun than Neptune does. For the little guy, that means it sneaks ahead of the big one. You might naturally ask, wait, why don't they smash into each other? Well, the answer is kind of magical and mathematical. Gravitational gymnastics. As soon as Pluto was discovered, astronomers got curious about its strange motion. While the other planets glide near the Sun's equator, the strange looping path and tilted orbit of Pluto made people scratch their heads. Eventually, they came to a mind-blowing conclusion. Pluto's orbit actually sounds like a recipe for disaster. It crosses Neptune's, right? Wrong. Because there are some baffling rules in the universe. One of those rules comes from something called the three-body problem. Imagine trying to predict how three space objects, say Pluto, Neptune, and the Sun, pull on each other and move as a result. It's like juggling three balls made of magnets in zero gravity. It's chaos, but surprisingly organized chaos. Scientists use weird and wonderful terms like non-concurrent libration, orbital precession, and VZK wobbling to explain what's happening. In the case of Pluto, the non-concurrent libration with Neptune basically means this. When Pluto's path intersects Neptune's, they never cross over the same place at the same time. They ensure that they travel at least 90 degrees apart around the Sun. Kind of like roommates who never bump into each other because they use opposite schedules. Orbital precession adds another twist. This is the slow wobble of Pluto's orbit, as it loops through space. When Pluto gets near, it's usually much higher or lower than Neptune's orbital plane, like passing over someone's head on a trampoline. That difference in height acts like a cosmic overpass, safe and sound. Then there's the VZK wobble, a delightful mouthful named after three researchers who studied how gravity dances between multiple space objects. That wobble provides an explanation for how Pluto can have such a weird path but still follow it consistently for billions of years. Think of it as a strange groove in space that Pluto gets locked into. So even though it looks like Pluto is bouncing around like a drunken satellite, it's actually tracing a very steady, predictable path. These mechanisms for gravitational balance work together like the world's most complicated ballet, keeping Pluto and Neptune from bumping into each other. The whole thing shows just how mind-bending celestial mechanics can be. Back in the 1980s, computer scientists ran simulations and discovered that even with all these stabilizing features, Pluto's orbit is still technically unstable. In the same way that a person walks a tightrope during an earthquake, small tweaks to its starting position could result in wildly different future paths. And yet, over the long haul, millions or even billions of years, Pluto somehow manages to remain in line. What's even cooler is that it's not just Neptune. Protecting Pluto, the giant planets like Saturn and Jupiter contribute their gravitational muscle too. Jupiter's pull, especially, acts like a space bouncer, making sure Pluto doesn't wander off into trouble. Saturn adds a little support as well. All these forces combine like cosmic referees, making sure Pluto keeps spinning without crashing into anything or flying off into deep space. Without this gravitational teamwork, our solar system could be total mayhem. Collisions between planets, asteroids going rogue, moons breaking free. Yikes. In Pluto's case, its oddball orbit could have spelled doom if not for the invisible dance moves that maintain gravity and keep everything in harmony. The idea that Pluto and Neptune might one day collide makes it all the more crucial to keep watching. Pluto's journey can be traced through these movements. It's a wonderful illustration of how chaos can coexist with stability. It teaches us that the solar system isn't as tidy as we once thought. It's more like a giant, delicate machine where every gear has to be in just the right spot, or else. Scientists fear that the whole thing could collapse. They call this orbital chaos, which is basically the idea that a tiny change in a planet's position or speed can lead to totally unpredictable outcomes down the road. To figure this stuff out, researchers run thousands of computer simulations, tweaking Pluto's position just a little and keeping an eye on what happens. And what they've seen is mind-blowing. A small adjustment now can completely reshape Pluto's orbit after some time has passed. Still, even with all that seeming chaos, Pluto's orbit somehow stays steady over absurdly long time spans. It's like a cosmic illusion. The path looks random, but it's actually quite consistent. However, anticipating this kind of movement is super hard. The farther out you try to predict, the more your guesses can go off track. It's kind of like trying to predict the weather in 100 years. One minor oversight at the outset results in the whole prediction becoming useless. That's why astronomers always leave some wiggle room in their models. They know Pluto doesn't like surprises, like the universe does. It is not only a sign, but also a symbol of chaos, of how far we've come in understanding space. Even though we've made massive leaps in astronomy, Pluto reminds us that there's still a ton we don't know. The way Neptune, Jupiter, and Saturn interact with Pluto shows us just how interlinked the fate of a tiny planet could be, dependent on a massive one's gravity from millions of miles away, which brings us back to those modern concerns. Why are Tyson and Kaku raising alarm bells? Tyson, whose name is synonymous with helping get Pluto demoted to dwarf planet status, has always been a loud persona when it comes to clearing up our misunderstandings about space. He doesn't observe the reclassification of Pluto as an insult, but as a much-needed update to our cosmic dictionary. His excitement for science is contagious, and he sees Pluto's messy orbit as a clue that there's still plenty to figure out. Still, even he acknowledges that Pluto's path could spell trouble if things change enough. Tyson isn't making wild predictions for fun. He's looking at data, tracking changes, and acknowledging that, while unlikely, a Pluto-Neptune collision isn't completely out of the question. If something throws off Pluto's orbit, say a passing comet or a gravitational nudge from another planet, it could one day end in a crash course. So the major issues are Neptune and Pluto both safe? Would they survive the impact? Or would we get a brand new mass of ice and rock where both planets used to be? While there's no solid evidence that such a collision is coming, Tyson's cautious warnings remind us that the motion of planets is not a joke. The more we comprehend, the better we can prepare. This isn't just science fiction, it's a reminder that we're still in the early chapters of understanding our solar system's future. Studying how planets, moons, and other objects all interact helps us plan for the long haul. Whether Pluto will stay on its winding path or veer off into something much more chaotic is still unknown, but its story keeps us hooked. It's the tale of a tiny world dancing between destruction and harmony, reminding us how even the weirdest objects in space can have an important role to play. When Pluto was first noticed, it was just a speck, at the extremity of everything. But it is now a symbol for the surprises space holds, for how far science has come, and for the mystery that still surrounds the universe. Even though people debated whether Pluto should count as a planet, one thing's clear: it grabbed our curiosity and never let go. As telescopes and computers become more powerful and faster, we'll keep uncovering more about Pluto, Neptune, and the mysterious mechanics that bind them. Each new data point brings us closer to understanding the ultimate fate of our solar system. Whether a collision is coming or not, Pluto's strange, swerving voyage offers us a seat at the table where the wonder and weirdness of the cosmos play out, and that's a journey worth watching. The adventure into space has barely begun, and Pluto, with all its quirks and irregularities, remains a key player in that story. Even though it's small, cold, and far from the center of our solar system, it represents something much bigger: our endless curiosity and drive to explore the unknown. Each time we study Pluto's orbit, its strange dance with Neptune, or its place in the Kuiper Belt, we're really asking deeper questions about the nature of space and time. Could other planets have orbits that are just as bizarre? Could another distant celestial body beyond Pluto be pulling strings behind the scenes? These are more than just sci-fi musings. They are the kind of inquiries that result in actual discoveries. The concept of a potential Pluto-Neptune collision, while far-fetched and unlikely anytime soon, forces us to re-examine how fragile orbits can be and how little we truly understand about the long-term behavior of the solar system. After all, Pluto's current trajectory is the result of billions of years of gravitational tug-of-war, and even a slight nudge caused by an unseen object, a passing star, or some mysterious force could push things off balance. This is where modern-day space science shines. Using ever-advancing computer models, researchers can simulate how small disruptions might affect Pluto's path centuries from now. These aren't just academic exercises. They assist us in preparing for a variety of cosmic possibilities. Understanding orbital dynamics at this level could even assist us in locating hazardous asteroids, preparing for missions to other planets, or predicting how Earth might change over eons. It's all connected, and we can't forget the human element in this story. Researchers such as Neil deGrasse Tyson and Michio Kaku aren't just warning us about Pluto and Neptune for dramatic effect. They're encouraging the public to take interest in the mechanics of the universe. They wish people could comprehend that space isn't static, it's alive, constantly changing, full of patterns and surprises. That's what makes celestial mechanics so fascinating. It's a combination of rigid physical regulations and unpredictable behavior, a bit like a cosmic chess game played over millions of years. Even though Pluto is no longer officially labeled a planet, its story continues to inspire. It reminds us that science is never finished. It's always being revised, updated, and challenged. Pluto's downgrade to a dwarf planet sparked debates around the globe, not just about astronomy, but about how we define and categorize the world around us. That conversation alone brought space science into the mainstream in a way few other discoveries have. At the heart of everything is a simple but powerful idea. Even the smallest object in space can teach us something huge. Pluto, with its icy crust, thin atmosphere, and wildly tilted orbit, may seem like an outlier. But it's precisely because it's so different that it matters so much. The more we study these oddballs of the cosmos, the more we realize just how diverse and dynamic our solar system really is.